I have started recording the class in cloud. The online people, Reed, Kelly, and Grace, can you hear me?
Yep.
I did not hear you.
I can hear you.
Okay, good. Very good. So we are going to learn time series. Time series. Today and next Thursday, we are going to learn MA, known as the moving average. MA, moving average time series model, and then AR, autoregressive time series model, and ARMA, autoregressive moving average time series model. Okay, these three model and previously 14 model. We have learned altogether 17 model, and the project that I will give, there will be 3-4 models, and which will be, you have a freedom. Okay, you have a freedom to do that. I will discuss that thing in next class. Ready, right? Time series. So let me start with the moving average model. I draw some figure and also a table of data. From there, you will understand how moving average model will work. Okay. So first, maybe 30-40 minutes, 45 minutes, I will discuss this thing. Then I will go for the estimation. Okay. Your homework is super easy. Please read the homework carefully. I clearly mentioned provided R code. I also uploaded an R code. Okay. I also uploaded an R code. Okay. Okay. Suppose I want to do a car sale example. Car sale example. I want to do a car sale example. So suppose a new showroom of a car company is open, and here is the data, day, here is a prediction, here is a actual value, and here is the error. These are the things. Okay. So day, suppose I have day 1, day 2, day 3, and day 4. These are the 4 days, suppose. Okay. And first day, I do not have anything is in there. How can I predict? Okay. I do not know anything in there first day. Okay. But actual value, we sold 4 cars. Okay. And there is no error first day. Now, in the second day when we are opening, try to understand. In the second day when we are opening, we now have previous days sales data. We can predict that we can sell around 4, right? Suppose we make a prediction of 4, okay? But actual value, we sold 10, okay? So now our prediction is this, but our sales value is this. What is the error? -6, right? -6 is our error, right? -6 is our error. Now I want to predict in here by using a formula. That formula is known as the moving average time series model. Understand? Okay. But before that, suppose I want to write here, this model has a mean like 4. And then this is a number psi, which is equal to suppose negative 0.5. This is purpose is to estimate this. Are you understanding? Now suppose I want to do psi 1 equal to negative 0.5, okay? Negative 0.5. Then later when I will derive all of those mathematics, then you will see how, but now I can say that these things, okay? Clear, right? Now I want to predict in here 4 plus my error, which is equal to minus 6 times minus 0.5. Okay. So I have in here 7 is the value. Okay. But actual number is actual sales figure is 14. Okay. So what is the error? Error is 7. Clear, right? Error is 7. Now let us come to the 4th day. Our mean, that means intercept, you can say something like that. Our, and then this is my error times minus 0.5, right? Then we have here 7.5. Okay. So the actual value is 9. Okay. So error equal to what? Minus 1.5. Let me put it in this format. Then I can go like this, go like this, go like this, go like that. Okay. So this is the way things is going. And now if I want to draw it, if I want to draw it in here, if I want to draw it in here, suppose I want to draw it in here. And I want to draw it like here. This is equal to 4. This is equal to 8. This is equal to 12. This is equal to 14, something like this. So on day 1, this is day 1, 2, 3, 4. Day 1, I have 4, which is equal to this. Okay. Day 2, I have 10, which is equal to this. Okay. Day 3, I have equal to 14, which is equal to this. And day 4, I have equal to 9, which is in here. Which is in here. 10, 9, yeah, which is in here. So now, this is the actual series. Okay. Now, what is the predicted series like this? If someone asks me, so 4, this is the 4, and this is the 8, this is the 7. Okay. The predict at 3rd day, it is, sorry, at 2nd day, it starts from there actually. It actually is 2nd day, it is 4, right? 2nd day, it is 4, right? So what I write, this is not a good thing. So this is the 1st day and 2nd day is this. And then 3rd day it is 7, which is equal to like this. And then it is 7.5, which is in here like this. So 3rd day is this and 4th day is this. This is called the predicted one, right? So now if someone asks me, okay, this is the thing, could you write the model? The model is moving average model. moving average time series model is written as YT equal to mu is the mean, and then you can put here like this, epsilon t minus 1 plus epsilon t. Okay? And this is known as, written as moving average with 1. That 1 is known as the lag, L-A-G, lag. So that means response variable is model for the 1 unit lag of the error term. Okay. So the error, so those are the table, and this is what the real model was. Are you understanding? Didn't you see I have this and I am multiplying this and that, and then get that one, the prediction one? You understand? So that table, that figure, and this is the mathematical formulations. Okay. And Yule in 1926, he come up with these ideas. Clear, right? Everyone understand, right? Any question? No. So if do not have a question, let me write the clear definition. According to this formulation, I want to write a definition. Okay. So now in this case, if I add one more lag term, then it will be MA2. Okay. This one stands for, this is a lag, LAG, lag T minus 1. If there is a lag 2, then there will be maybe psi 2 and then epsilon T minus 2, something like that. Okay. So now the definition, like how to write it, how to write this mathematical equation in some words. If this is the thing that you ask me, then I can write MA model predicts MA. So I put here Q, the Q leg, then Q could be 1, Q could be 2, Q could be 3. MA model predict MA model predict future values of a time series. Future values of a time series using past errors. Okay. So this mathematical model is defined by this sentence, MAQ, defined by that sentence. Okay. That mathematical model is defined by that sentence. MA model predict future values of a time series. YT is a time series, and that time series future value will be defined by past values, like past values of the errors. Okay. And I showed you the example, right? So in your interview question, you can get 1 or 2 questions from the time series. Okay. And I have uploaded beautiful videos. You can see those things. Okay. So after that, maybe I can upload this one too, if you want. Okay. Now I want to tell you, I want to very clearly define what is the definitions between ACF and PACF. Okay. This is known as the auto correlation function. Auto correlation function. Question? And that one is partial autocorrelation function. Partial auto correlation function. Okay, autocorrelation function and partial autocorrelation function. So in order to define that, there is a way to minimize this panel. I think here. Yes. And then I have more space now. Okay, autocorrelation function and partial autocorrelation function. In order to do that, let us define a series. Okay, let us define a series, then you will understand. Suppose I have a time, and then I have a series, current series, which is known as the YT. Leg 1 series, leg 1 series, which has y t minus 1. Leg 2 series, leg 2 series, which has y t minus 2. And let me define another one, leg 3 series, y t minus 3. Okay, so suppose I have time 1, 2, 3, 4, 5, 6, 7, 8, 9. These are my series. Suppose this value is 10, 20, 30, 40, 50, 60, 70, 80, and 90. Okay. So now leg 1 series, this is missing. So it is coming here 10, 20, 10, 20, and then 30, 40, 50, 60, 70, and 80. Here, this one and that one is missing. So this is 10, 20, 30, 40, 50, 60, 70. These things is missing. 10, 20, 30, 40, 50, 60. Okay, suppose this is 10 and this is what? This is equal to 90, this is equal to 80, and this is equal to 70, and this is what I want to predict. Are you understanding? Are you understanding? I want to predict like this way. Clear, right? Now take a look at that. If I take these things, draw, if I take the correlation of these, then it is called the autocorrelation function, okay? Okay. Now suppose I want to take out this. I want to take a correlation between this and that. No, that is still, that is a, okay. Okay, let me rewrite these things. As you are already going to the partial, I have to explain these things. So the correlation between this and that, is known the autocorrelation with leg Clear? Leg 1. So now, if I want to do the autocorrelation between these and that, autocorrelation with lag, similarly, it will continue. Okay. Now, if you take autocorrelation between this and that, it will be again lag 1. Okay. If you take autocorrelation between this and that, because there is a 1 lag, right, between them. Clear, right? So now if you take the autocorrelation between this and that, suppose this is tan here. If you want to take autocorrelation between this and that, then this will be autocorrelation with lag 3. Clear, right? This is good. Now take a look. When you consider the autocorrelation between this and that, within that, this and that series will also include, right? This and that series will also include, right, in here, because you see tan 20, right? So in this case, if you come in here, 30 is in there, 40 is in there, 50 is in there. So this 50 is in there, 60 is in there. So that is why it is written autocorrelation function induces all direct and indirect effect. Are you understanding? That means, do you understand what do you mean by direct and indirect effect? Direct effect means this and that, and indirect effect means this and that also are considered in here. Clear, right? What is autocorrelation? Autocorrelation function is that. Now, online people, are you okay? Reed, Kelly, Grace, are you okay understanding? You are okay, right, online people?
Yes.
Okay, good. So now take a look. If I want to predict these things, then I have to use these values, right? These are my 1 lakh values, 2 lakh values, 3 lakh values in order to that. Now, what is partial autocorrelations? Partial autocorrelation means, so you understand direct and indirect effect, right? Direct and indirect effect. Direct and indirect effect, that means I am finding these two series, but other series values is also in there. So that is why I call them. But in partial autocorrelation, they move out all the other effect. How? If you want me to write, I can write it in this format. Then I will write the equation in order to explain partial autocorrelation. ACF induces all direct and indirect effect through the intermediate effect. And suppose I want to fit now YT predict with using beta 0, beta 1 Y t minus 1, beta 2 Y t minus 2, and beta 3 Y t minus 3. And suppose this is beta 4 Y t minus 4, and then this is my epsilon t. Understand? So in the model, how many legs I used? Up to 4 legs. So I said that in order to predict YT's current value, YT is my current series. YT is my current series. In order to predict my YT value, that means current series, I have to take help from the 4 legs of the previous, right? 4 legs of the past values. So leg 1, leg 2, leg 3, leg 4. So I have these data, I fitted these things, then I estimated these things, okay? This one is my estimation. Okay? I have estimated this, and once I have estimated this, I do not need to have these things. In such a cases, this is the partial autocorrelation function for leg 4. This one is the partial autocorrelation function between this and that. Understand, right? Previously, YT and YT minus 1, YT and YT minus 2 from the data. But now you are obtaining it by fitting the model. Once you fit the model, this is what known as the partial autocorrelation function. Okay? With the leg 4. But this one are not. Partial autocorrelation function for the leg 1, leg 2, leg 3. Are you understanding? So now your question is, hey, professor, tell me how can I find partial autocorrelation function for leg 3? If this is your question, then I have to ask you, then you have to write this model up to good, up to 3. Then this is the partial autocorrelation function for the current series and leg 3. Are you understanding? This is called the partial autocorrelation function for leg 3. You will get 2 interview questions from time series, these 3 model. But for the project, I'm not going to ask question, okay? You understand, right? Okay. So if you understand these things, now let me take you to the theory. Okay? Let me take you to the theory. People are saying my class is very hard. I don't know why you are saying so hard. I think this class is the most easiest and interesting class. I guess so. I don't know whether. I'm not going to ask you, okay, come derive this mathematically. If you cannot derive it, I'm going to beat you. I'm not going to tell that, right? Or I'm going to punish you. Right? Did I give you all the question is just conceptual question, right? Conceptual question and the homework. And homework is also, most of the time I provided the R code, and all the R code, Python code are available. Okay. Moving average. Okay. Let me start moving average now. General linear process. General linear process. A general linear process YT is one that can be represented as a weighted linear combination, as a weighted linear combination of present and past present and past noise terms. Noise means error. So this is known as the linear process. And it will go like this. Now see, if these things is really infinite series, okay? If this series is really an infinite series, okay? Then it will explode, right? It will become infinity, right? So why 0 times anything equal to 0? Why 0 is so powerful? Why 0 is so nasty? Do you understand? So nasty 0, right? It makes everything 0. 0 times anything equal to 0. Why 0 times anything is not equal to that number? What power 0 have? Do you understand? Did you think about that? So if you have a suppose being 1 billion, right? Suppose 10,000, right? I multiply it by 1, it is 10,000, right? Whatever number you can bring, I don't care, just bring it. So now if you multiply it by half, then if you multiply it by 0.1, then understand? I'm going to 0, right? So 0 is so dangerous. So I don't care whatever things you have bring. Okay? Whatever things you have. That's the reason. So whatever things you have, if you go down, it will become 0. So if I can successfully see what was my question? Suppose this series is an infinite series, is go up, go up. Okay? Go up, go up. If I can put something in there so that even if the series is infinity, but there is a finite number when I add all of this. So for example, you know this, right? 1 minus a to the power minus 1. You know this, right? This is 1 plus a square plus a cube plus all the way up to infinity, right? Do you know this? Yes or no? But can you prove it? Take a look. Suppose s equal to 1 plus a square plus a cube, and it's go all the way in here, right? Now, if I multiply it with a times s, then I have a plus a square plus a cube plus a4. It will go all the way, right? Right? So if this is your equation A, this is your equation B. If you do A minus B, then you are getting what? If you are getting 1 minus A S equal to 1, right? Then S equal to 1 over A, 1 minus A to the power inverse. Under the condition is what? A is, that is the condition, right? 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 Are you okay, Latifa? Confusing? Is it going over your head? How about Nusrat? You understanding this?
No, I'm trying to connect it to the general.
That series?
process. Yes.
Yes, you want to connect that one, right? So do you, if you want to connect, are you seeing these things? So then what would be in that case? I do not have a control on error, okay? I have a control on psi. If that series is infinity, if I put a condition on the psi, that psi cannot take values. Psi can take values between -1 to +1, that's it. Okay? -1 to +1 means decimal negative number or decimal positive number. Okay? Then whatever infinite series you bring, I will have a finite or closed form solution. Okay? We like closed form solution very much. You see all the regressions except what it called like those simple multiple and Rees lesser inelastic net. All other you have to take help from Newton-Raphson method, right? All of them does not have a closed form. So they are saying in here. So basic of moving average model, I already discussed in the first 15 minutes. Okay, first 15 minutes I already discussed. Now I am discussing how to estimate this. Okay, so now I want to write here, if the right hand side of this expression is truly an infinite series, after that I am writing this. If right hand side of the above series is truly an infinite series. If right hand side of the above expression is truly an infinite series, then certain conditions must be placed on psi weights. For the right hand side to be meaningful mathematically. For the right hand side to be meaningful mathematically. To be meaningful for our purposes, it suffices to assume that sum of psi I square weight must be less than infinity. I goes on to means and psi 0 equal to 1. So psi 0 is the coefficient of ET, which is a coefficient of E0, ET, which is the coefficients of ET. That means that one, psi 0, which is equal to 1. Okay, so now suppose we introduce these things. Psi j are my coefficient. I have introduced that this is equal to that. Okay. Where absolute psi less than equal to 1. That is the condition. So take a look at that. Now it will be replaced by this psi, this one, and this will be replaced by that. Okay, that will be replaced by this. So if there is a 1, so then it will be 1. If there is a 2, then it will be 2. Okay, if there is a 1, then it will be 1. If there is a 2, then it will be 2 is in there, under the condition that these follow that restriction. Okay, this follow that restriction. So now big equation, I just want to consider a two-leg model. If I consider two-leg model, then take a look at that. The previous series will reduce to that ET plus this one, and then ET minus 1, this square, ET minus 2. This is what? This is a moving average. If someone asks me to write it, it could be moving average with lag 2, up to 2 lag in there. Okay, it is written like that way. Clear, right? Remember, your homework is very easy. It is just finding some autocorrelation and their like relationship. Okay. So from there, let us go and try to do some computations. Okay, I want to do some computations in here. In this case, if we assume expected value of yt, which is equal to 0, because this arrow term or noise, they have a mean always 0. Okay, so if I take this now, so expected value of ET for equal to 0 for all value of t. It doesn't matter whether t minus 1 or t minus 2 up until all of these legs. Okay, this is always 0. So from there I got this 1. Now if I want to find variance of yt, then it will be variance of this one, which is equal to sigma square f error plus pi square sigma square of error, then pi to the power 4 sigma square error. Okay. So now if you want to take the sigma square out, then you are getting 1 plus pi square plus pi to the power 4. Okay, for this one. But suppose your equation is this. Suppose your equation is this, ET phi E t minus 1 phi square E t minus 2 phi cube E t minus 3 phi 4 E t minus 4. Suppose this goes like that way, then it is mean still equal to 0 and variance of yt equal to what? If I follow this formula, then it is sigma square 1 plus phi square, phi to the power 4, and phi to the power 6, right? There is a phi square, phi cube. So it will be 6, right? Or 8. Okay. So then it will go like this way, which you can write sigma square 1 minus phi square like this. And then you can write here sigma square E, sigma square E, sigma square E, 1 plus 1 minus. One minus phi square. So that means for this infinite series, variance equal to you are getting clear? Because this follow the formula that I previously discussed. Okay? The formula that I previously discussed, this follow that one. Now I want to find the covariance. See, two series, one is current series and one is past lag one series, right? So I am finding the covariance between current series and the lag one series. So then I have to write it like covariance of ET plus phi ET minus 1 phi square ET minus 2. It will go like this, then this, comma, another series is E T minus 1 phi E T minus 2, and then phi square E T minus 3. It will go all the way like this. And then take a look at this one. So this and that has a match in terms of error term, right? So if there is actually the covariance formula is this. Let me explain this. Covariance of x comma y is written as expected value of x y. That means they are joint expectation. X times y minus expected value of x times expected value of y. This is the way you can multiply them, okay? This is the way you can multiply them. So now if you this and that multiply, this is the formula. So I cut it short. So now if you multiply this with that, then there is a term. So I can write it as a covariance. Covariance means joint variability. If it is the same quantity, then it will become variance, okay? So now phi E T minus 1 and then E T minus 1 plus covariance of phi square E T minus 2, and then here is phi E T minus 2, and then it will go all the way. So these are there is a similar term. There is a similar term with the number of legs. And then non-similar term covariance will become 0 because there is only error term and then expected value of error term equal to 0. But expected value of error square is not equal to 0. It is not equal to 0. Expected value of error term equal to 0. Okay, this is true, but that is not. This is true, but that is not. Okay. If this is the case, if this is the case, now if I want to write it, I can write here, this is phi sigma square E, because this is coming sigma square E. And this one and that one become phi cube sigma square E. And then phi 5 sigma square E. That will go like this way. Then if you take phi common, sigma square E common, then 1 plus phi square, phi to the power 4. It will go like this way. Then you can write here phi 1 over phi square and then sigma square E. So this part is equal to that part, which I have shown you before. Are you understanding? Okay. So now we have what? We have these things. We have for the infinite series. For the infinite series, for the infinite series, we have expected value of yt equal to 0, variance of yt equal to sigma square divided by 1 minus phi square, and covariance of yt and lag 1, which is equal to phi over 1 minus phi square sigma square. Let me put here E, let me put here E. Okay, so these are the three quantity we got. Okay, these are the three quantity we got. Take a look here. I got the lag 1 covariance, right? You can also find similarly lag 2 covariance, lag 3 covariance, lag 4 covariance. Understand, right? So now, what is the correlation formula? You know, correlation formula is this: covariance of x comma y and divided by variance of x and variance of y and square root of that. This is the correlation formula, right? Do you remember that or not? From econometrics class, you should remember that. Did you take the econometrics class or not? This is the covariance correlation formula, correlation between x and y. Now I want to find correlation, like correlation known as yt and yt minus 1. So I can write here covariance of yt and yt minus 1, and then here I can put the variance square, right? So I can put here variance of yt and variance of yt minus 1. If this is the thing, if I put it in there, then what I got it in there. So see, you can ask me, hey professor, there is a t minus 1, but there is a t. How these two terms could be the same? This is your question, right? Now take a look at that. If you take a look at the series, this series, right? This is the series. Okay? This is the series. Suppose if I want to write here t minus 1, then it will be 2, it will be 3, it will be 4, it will be 5, but it is still infinity, right? So then if I take the variance, still the same, right? Are you getting it? So at home, when you read these things, this theory, if you are interested to learn the theory, if you read these things, so just think that way. Right? There is a mathematician among you, okay? She might be interested. Okay, now if you plug this value, covariance, I want to put there phi 1 minus phi square sigma square E, and then I want to put here 1 over phi square sigma square E, 1 over 1 minus phi square and sigma square E. So that means there is a 2 quantities in here. So that means this is like this. Okay. So then I remove it, this and that cancel. So what I have in there, 5, I have a, I have a quantity like this, phi over 1 minus phi square, and then I have 1 over 1 minus phi square. Here is sigma square E, here is sigma square E, this and that cancel, this and that cancel. So I have just the phi. So correlation of yt and yt minus 1 equal to what? So phi is what? Original series has a psi. Psi was replaced by, understand? And phi is, no. Original series was psi. Psi j equal to phi to the power j. Okay? Right? Phi to the power 1, phi to the power 2, phi to the power 3, right? Let's go. So that means psi j is replaced by the phi j. See, this is psi j, which is replaced by the phi j. Okay. So now all coefficients is starting in this format, yt equal to epsilon t plus goes right all the way. Okay. So in this model, what is unknown? Right? Error the way we got, we can error that way, right? In the first example, car sale example, you remember that, right? But what was unknown? Psi. And in that example, I consider phi equal to what? Negative 0.5, remember? But now you know how to compute psi. Psi is nothing but the understand? So when I put negative 0.5, why didn't you fight with me? Why did you put 0.5? Do you understand? When I did the first example, I put mean equal to some number, and then I put psi equal to negative 0.5. Okay. So if your model is like this, And then if you plug it with that psi as a phi to the power j, okay? So that means it is a correlation coefficient of the y and yt minus observation. So see, this is the correlation between yt and yt minus 1 observations, okay? So how can you find that the correlation between yt and yt minus 1 observations? This is yt and yt minus observations, right? So this is what you will find. Then you can use that psi to update your informations. You work in a car company and you have, suppose you work in a car dealership, okay? Every day they sell the car. And then you can make a very beautiful prediction of this. You can say, you can see to you are just a salesperson. Okay, by the way, the people who work in the like car sales company, especially Toyota, okay, those people, they are making a lot of money. They are making a lot of money. And if they find a like people like very simple, how can I say, should I use that word? Like the gullible, you know the gullible word? You haven't heard the word gullible, like the person who are foolish type? Gullible. If the car sales company, if they find you that you do not know anything, oh my goodness.
They will rip you.
You cannot believe in 2014, a guy from Bangladesh, he's a medical doctor, came here. During that time, Toyota Corolla was selling 14,000 to 15,000, not more than 15,000. At best, 15,500, okay? Oh my goodness. He came up with buying the car in 26,000. And then he came to my home because by that time I already bought a new car. Nissan Altima 2012, I bought it. And when he came, he said that again. I said, what? And he was very upset for a couple of weeks. And it is true, right? It is true. Any person, even if he is a millionaire, if he lost like $10,000 for it. So I went there, I have some money cash I brought from home, we need a car, we went there. And he was really, really gullible, foolish guy. He does not know about any other. Like all of his home activities is run by his wife, actually. Okay, very simple guy. So I still remember that. So when you go to buy the car, be careful. Okay, do a lot of research. And if you work as a representative in any sales company, the example that I have provided at the very beginning of the class, use that. Okay, use that. I provided you this data, right? So you have a how many 30 days data. You have started working there 30 days. You can go to your manager. Can you give me the data for the last 30 days? How many cars you sell? Just say that, give me the data and the 30 days sales data. And then you make a series, right? Leg 1 series, right? And then after leg 1 series, you computed what? Correlation coefficient, right? And then correlation coefficient you have, that's it. This is what you need, like correlation coefficient. And this is the things that you are coming from the error, okay? Then you can complete the entire chart. Then you said that, well, we sell these things, next day we can sell this. And then if you perform good, your manager is happy, then you can promote you. So manager always like to eat food from the head of his employee, okay? You understand? So if you are a smart guy, you have to convince one, and then few months later, you see the people who are working for 10 years, 7 years, they are kicked out, but you are in there. Okay? So you got, right? That is why I did not tell you at the very beginning how I will estimate this. So I have shown all of this. This is nothing but the correlation coefficient, okay? So this is nothing but the correlation of these things that I have started in. This is the thing, okay? Okay, so we have done these things. Now let me do. Now, one thing that I wanted to show you, I have shown correlation coefficient between yt and yt minus 1 is phi. This is what I just showed you, right? So now if you can ask me, what will be the correlation? Is there any general formula that I can find correlation coefficient between original series and a K leg? Okay, so this is the formula between original series and K leg. Okay, similar procedure if you follow and compute covariance, and you will end up with this formula. Okay, similar procedure if you follow, then you will end up with these things. Okay, then if you want me to write the covariance of that, covariance of YT and K leg. First one is leg 1, right? Now this is a K leg. If K leg covariance is this, sigma square E 1 minus that. This is the K leg. So take a look at that. This autocovariance depends on the number of legs, but does not depend on the T. Does it depend on the T anywhere in the T? Are you saying it is depend on the number of leg, K, right? K is in there. And if you see K is in there, is there any T? No T, right? Time changes, but leg is fixed. Leg is 1, leg is 2, leg is 3, leg is 4. Understand? Time changes, but leg are fixed, right? Okay. So in your variance, covariance, and correlation structure does not have a time variable, then that series is called the stationary. Are you understanding? So let me write it. The expression of the expressions of mean, variance, covariance, and correlation does not depend on time. That means T is not in the expression. Okay? But time lag. Time lag K, which is a fixed number, which is a fixed number. Then the series is called stationary. Do you understand these things, what I said? In the expression, any involvement of T or S, nothing, right? But the leg difference, how many legs are in there? So that means the series. If, like when I taught this time series class for the PhD student in my previous institutions, they have to hear these, all of these things mathematically during the class exam. Okay? So I give them a series, I make them, and they have to find the mean and variance and have to express the closed form that expression does not have a T. Time is not in there. See, time is in there, no, right? It is a K. So that means the series that I wrote, it is stationary. Why stationary is important? Stationary means stability. I can predict them. So which you will see It is called volatility. So stock price is going like this way, right? Suddenly, Elon Musk said something, then he started like this way. Okay? You understand? So then you can predict in here. How can you predict in there? This is known as the stochastic volatility. Okay? So there is a concept. What is the difference between random variable and stochastic variable? So random variable is again, so this is just the randomly taking. Okay? Randomly taking. This is a mapping from sample space to real net. But when there is a stochastic variable, this value changes with time randomly. Stochastics means time is a hidden another variable, so value changes with time. For example, yesterday's sales, today's sales, tomorrow's sales, day after tomorrow's sales, right? That is changing by time. Okay, that is changing by time. So you understand what is the autocorrelation function, what is partial autocorrelation function, and what is stationarity of a series, and how moving average model with lag 1, 2, 3 Q, those could be done. Okay. Okay, you can take 5 to 6 minutes break, then I will finish the other part. Let me drink some water. I will start at 7:20, okay? Okay, so I have derived some expressions of the series in terms of a series variance, covariance, as well as correlation coefficients. Okay, this is what, and I consider psi j equal to phi j, right? This is what I consider. Suppose you can ask me question, Professor, I don't like psi j equal to phi j. If you ask me question like psi j equal to pi j that I put, you said I don't like these things. Okay. Then what will be the structure of the series? Like what will be the expected value and what will be the covariance, something like that. So take a look at that. I'm writing it. In that case, the condition is that if the series is infinite, then you have to put such conditions in here so that series will be reduced from infinite to finite. Understand? So I am now just giving you mathematical expression how it look like if, let me put the black color, yt equal to et plus psi 1 e t minus 1 psi 2 e t minus 2, like this. So in such cases, I want to write like this: covariance of yt and yt minus k. Let me put it in a general format. Okay, let me put it in a general format. Then you have to write it covariance of et plus psi 1 e t minus 1 plus psi 2 e t minus 2 psi 3 e t minus 3, like this. And then I can write here another one, e t minus k plus psi 1 e t minus k minus 1 psi 2 e t minus k minus 2, and it will go like this: psi 3 e t minus k minus 3, something like it will go. Okay. So now if you take these things, covariance of, you will find these things. I have to find the quantity so that square term from the two things is coming. See, covariance means taking two expectation, right? As I mentioned in here, when you write it, covariance of x comma y means expected value of x comma y. Sorry, this is the multiplication minus expected value of x and expected value of y. This is the definition. So when you multiply it in here, you have to find something always e square. Otherwise, if there is a E, just E and non-matching suffix. So suppose there is a ET and ET minus K, then it will not matching. So that's then they are independent, so it's become 0. Okay, so I have to find here square quantity that match their like the number of legs. That is what. So if I want to find it in that format, psi k, then e to the power e square t minus k. So you can ask me if I get here psi 1, psi 2, psi 3, and I can get here psi k, right? That psi k is in here. Okay, that psi k and another psi k is that psi k is in here. With that psi k, I have e t minus k. I think you are not understanding what I want to mention. So let me tell you, if I extend it in here, I will get psi k and e to the power e t minus k, right? Psi k e t minus k, I will find it in here. That t minus k will go, e t minus k will go with this one. So that is why it is a square. Are you understanding now?
Yes.
And this psi k is coming from there. I need a square term of these matching. I want these matching. I do not care about this suffix. And then I want this one. Okay? I want that because that will give us some meaningful result. Other things will not give us the meaningful result. And then next one, if I want psi 1 and then psi 1 psi t minus k minus 1 will give us e square t minus k minus 1. Are you understanding how did I get this? This one is coming from there and this one coming from there.
It's just
Which one k minus 1?
without T.
No, there should be t. Because that one is coming from here and this one coming from there. There is no t in here? Here?
Side, yes.
No. It will go here, psi k, then e to the power. So you can put here t minus k. Yeah. So psi t minus k and e to the power t minus k. Right? It is reducing, right? T minus 2, t minus 3. So then it is did I miss something? Okay, let me rewrite these things. Can you help me or I have to rewrite these things?
It's just T minus K.
Just K minus.
So it's
T1. Psi 1, psi 2, psi 3, psi 4. Yeah, it's so
It should be k y psi k plus 1, psi k plus 2. It is increasing, right? It is increasing, right? So that is what I need to change it in this format. It will go like this way, psi k and e to the power t minus k, right?
Yes.
So in order to match this, so that if you want to write psi k plus 1 e to the power t minus k minus 1, right? So now then it will be what? Psi to the psi k, right? Happy? Right? So now it will continue. So then it will continue means now if you find their covariances, all of these things, and these will apply on there, these will apply on there, and then covariance become variance, right? Okay, so covariance of x comma x equal to variance of x, right? Right? So if you write like this way, variance of x equal to what? Let me again give you some definitions. Variance of x equal to expected value of x square minus expected value of x whole square, right? Now covariance of x comma x equal to expected value of x times x minus expected value of x and expected value of x, which is equal to expected value of x square, which is equal to variance of x. Okay, so it is covariance on this, that means x square equal to variance. So it become all sigma square, and these weights could be written as like this: psi I and psi I plus k. I goes 1 to I goes 1 to infinity. I goes 1 to infinity, and then sigma square. I goes 1 to infinity. There is if I equal to 0, it is 0, and then it should be sigma square e. So that is the expression if you do not like psi equal to phi. Understand? That is the expression for the covariance if you do not like psi equal to phi, and then similarly we can also find the variance formula. Okay. So general thing is done, general formation is done. Now if someone come and one day tell you, well, you learned something that everything is additive. This could also be your moving average model. Okay, this could also be the moving average model. If there is a subtractions, do not get angry on someone. Okay. Previously, what we did, what we did previously, this is up to order k, moving average model up to order k or leg k. Understand? I stop in here. Okay. So previously I started the moving average model where everything was in additive term. Okay. Now it is just the negative. But if this theta 1, theta 2, if they could be theta q, if they could be negative number, then everything will be positive, right? And in their original model that I wrote, in that model, if everything is negative, then positive model become negative, right? So that's the reason this is also another expressions of the moving average model. And previously I said it was developed by something, but he developed the autoregressive model. Moving average model was developed in 1927 and 1938 independently by Slutsky and Wald. Slutsky and Wald. And Wald. Slutsky.
Yeah. WOL.
Yeah, very ugly O. Okay. So now if I want to do some computations for the first order, second order, then it will be the computations of the theoretical discussions. Okay. So suppose if I want to write like this, so yt equal to et
minus theta e t minus 1, and then expected value of yt equal to 0, and variance of yt equal to sigma square, and then 1 plus theta. So if I take the variance on here, variance of this equal to sigma square, and this will become positive because variance make the negative sign to positive, and this is the result for that one. Okay, for mean and variance. Now covariance. This is the first order moving average model. Moving average model with order 1. Okay, lag 1. Moving average model with lag 1. This is. Okay. Now if I want to find the covariance of yt and y t minus 1, this is the things if I want to find. What I have covariance of et minus theta e t minus 1, and then e t minus 1 minus theta e t minus 2. Now, if multiplication if multiplication takes place, see, this and that is a non-matching. Also, this one and that one is non-matching, right? And this one and that one is non-matching in terms of arrow term, okay? So what is the matching term? Matching term is covariance of minus theta e t minus 1, comma e t minus 1. So if it is written theta sigma square e, because this will become variance term. So see, first order moving average model which takes shape like this, has a mean equal to this, variance equal to this, covariance equal to this. Are you understanding what I did in here? If there is a first order lag or MA1 which has a lag of 1, and then if I want to find the mean which is equal to this, because that E is a arrow term, and then if I take the expectation, it will become 0. Okay. So for this one, if I want to write expected value of yt equal to 0, variance of yt equal to sigma square 1 plus t, covariance of yt and y t minus 1 with this type of minus theta sigma square e. I have found lot of mean and variances, right? But you remember previous time, all the regression model, remember how many mathematics, how many things are computed? But here the model is computed in different approach, right? Are you understanding? No calculus was using in here. Are you understanding? Time series model, but calculus was not used. Differentiation is not used. They are doing some computations by using mean, variance, covariance, and correlation function. Because next time when I will discuss next week, instead of arrow term, I will model this by using, suppose I want to put here y, like arrow term t, and then I want to put here like phi, and then yt minus 1. See, past response depend on the current response. Are you understanding? Next class when I will discuss autoregressive model, I will discuss these things. Are you seeing what things we are doing in there? Both of them are dependent variable, right?
Only difference, there is a lag. So 10, 20, 30, 40, 50, 60, 70, 80, 90 is Y. And 20, 30, 40, 50, 60. One started from 10, another started from 20. Okay? So if someone who does not know about time series or anything, he will immediately ask questions. Then both side is random. Do you understand? If someone, he just know all the regression model, he never know about like these things. He will immediately ask questions. Both side is random. Left side is random, right side is random. YT is random. How can we compute all of these things? That is why the people who developed this 100 years ago, autoregressive model, they said this, even though they are taking multivariate format, because YT minus 1, right? If I add another one, YT minus 2, and YT minus 3, YT minus 4, then there is a multivariate distributions. How can we estimate this model? And then see the intelligent people, how they come up with this estimation. They are computing everything by focusing on 4 quantity: mean, variance, covariance, correlation. Very super talent, right? And see, the other regression model was computed by using differentiation, right? Yeah, you have a question?
Yes. So in case of moving averages, like, how do you know the extent to which number of lags to compute?
Okay, so he wants to know like how many legs we can add, 2 or 3 or 4. Okay, so after didn't I give you the example? That one, okay. Take a look at that. I know autocorrelation function, right? Autocorrelation function, right? And then autocorrelation function, you compute lag 1 autocorrelation, right? He actually asks a very good question. Lag 1, lag 2. So we can compute. And then take a look at that. I can draw the figure in here. I need to explain these things when but anyway, this is the. So this is a autocorrelation lies between -1 to +1, right? Right? And this is a lag 0. Lag 0 means perfect correlation, right? Lag 0 means what? YT correlation with YT. Okay? So then this is equal to that, right? Now you can compute 1 lag autocorrelation between this, right? You can find in here, this is lag 0, lag 1. You can find it in there. And then second one you can compute. Third one you can compute. Suppose this is your benchmark. I can go autocorrelation above 0.4. Okay, so I will use here 3 lag. If rest of the world will start crying with me, no, I add 2 more legs. I said no. Are you understand? If my boss, my mom, my spouse, there's no add 2 more.
So Professor, you have to compute.
Do you understand, right?
You have to compute ACF.
Yes. I should tell these things before. Why did I forget? Thank you. So this benchmark you have to set up, maybe you can take it 50%, 60%. No, I could take 70%. Then 2 lakhs. Okay. So similarly, if it is negative like this, now see another interesting thing. So suppose when you compute the lag, whether autocorrelation exists. So first things you need to understand. You are going to use the time series model, right? Are you understanding? You are going to use the time series model. How do you know the U series is actually autocorrelated series? You understand? Someone give you the data is coming by day or by hourly or by weekly or by monthly or by yearly, data is coming. You see the data, you say, okay, data come by time. Okay, first choice is time series model. Okay, by looking at that. So you get the first series by time series model. Then let me see how my correlation figure what. Okay, so you say that first one 0 correlation,
this is a 1, this is a -1. First one is always this, right? And second one you find like this, negative. Third one you find like this. Fourth one you find like this. Fifth one find like this. Okay? Sixth one find like this, right? So that means sometimes positive, sometimes negative. So there is not a consistency thing. Okay? On the other hand, you see figure like this. On the other hand, if you see that second was coming like this. So that means successive values is positively correlated. Okay? Successive value is positive and then it is negatively correlated again. So that means there is a pattern. Okay? Then you have to do this format. So if you have to take a look at the autocorrelation function as well as partial autocorrelation function. And if you see that there is a between first leg, there is nothing. Second leg, nothing. Third leg, nothing. Fourth leg like this. Okay. So that means you said that, well, every 4 months there should have some cycle. Okay. So you see that January, April, and then August and December. Okay. So 3 quarters. So that means, well, so their supply is going up during these times. That means they supply once for a quarter. Or maybe you say every other month supplying correlation is going up. Lag correlation. Correlation means lag correlation. Okay. That's the way you have to define. So you have to define how many lags you are going to add in your time series model. That will be determined by original series. You can make different lags and different columns of the values and just write one line of R code or Python code that will give you ACF plot and PACF plot. From there you can decide how does your model look like. Okay. Thank you for asking this question. I should answer this thing. I forgot actually. So now if I want to do yes.
This time series model, is there any difference between this one and ARDO models? The time series models,
Which is MA.
yeah. Is it different from ARDO?
Crazy white. Okay. Just a second. Hello. She said sorry. Okay. So I did not get your question.
Yeah, these MA models, are they different from AR, autoregressive distribution?
Yes.
What is it?
MA and AR is different. MA, we model to predict future value in a combination of errors. But here we model in a combination of past response values. Here is model on the response values. Don't you see that one? AR is, where is that one? Here, this is AR. YT depend on YT minus 1. But here, YT does not depend on the YT, it depends on the error. And how error we compute, that is what I showed at the very beginning of the class.
He was saying auto-regressive distributed lag.
What?
Is it, okay, that's AROT. Is it same thing as auto-regressive?
I don't understand the question.
That's it. You got a question?
Did I answer the question?
Yeah.
Okay.
But then he's selecting the number of lags with the AR models. You can use AIC or SIC. I mean,
What do you mean by AIC? No. AIC is different thing. Those are for the model selections for the simple, multiple, and then Poisson binomial. Those concepts should not be in here. So AIC, BIC, that is different. Okay. Okay, so I already said how the first order moving average model behave with their mean, variance, covariance, and correlation. Okay. So now take a look in the first order model. If I want to like this, covariance of yt and yt minus 2. Okay. If I want to write it, what was my yt? My yt was that I wrote very few minutes ago. This was my original one. Okay. So now I have in here et minus theta et minus 1 and then et minus 1 theta et minus 2. So in this case, et minus 1, can anyone of you correct me? T minus 2. Okay? Right? Any matching? Any matching? So then, okay? So now in summary, if we want to write this type of model, we have this yt equal to et minus theta et minus 1. And in such a cases, I have these things yt equal to 0, which is equal to variance of yt equal to sigma square e 1 plus theta square. Then this is called the covariance theta sigma square e and then rho 1, which is equal to minus theta 1 plus theta square, and this is equal to 0 2, because when this is greater than k greater than 2, k greater than 2. So let me rewrite these things. I'm messing up something now. K greater equal to 2. Are you saying k greater equal to 2, right? If you use this model for this in here, if you put yt minus 2, then yt1 and t minus 2 would not have any matching. If there is no matching, covariance equal to 0. If covariance equal to 0, correlation is also equal to 0. Clear, right? Let me do something for the second order, some computations. And then finally, qth order, I just write the formula how, but those computation could be done. I just write the formula, the final one, okay? So remember, if you work in any company that deals with the sales figure and then they want you to analyze their sales data, then this is the very beginning one. Okay, very beginning one. You can ask them, okay, give me some of your data, time series data, and the example that I give at the very beginning. Try to do these things by estimating correlation, and then you can predict, you can estimate all of these things and then compare what is their result and what is your responsibility, just to estimate correlation from the data. Make 1 or 2 or 3 leg, estimate the correlation and then see, and then you can tell your manager, tomorrow we can expect that, tomorrow we can expect that. In that way, if you have a 1 year data, then 365 days, then you can make a prediction. So weekly predictions, daily predictions, monthly predictions like this. Okay, that is the very simple one. So now if I have a second order, suppose I have a MA order 2, the model looks like this, YT equal to ET theta E T minus 1 and then theta 2, here is theta 1 E T minus 2. Expected value of YT equal to 0 because expected value of error equal to 0. Okay. Now variance equal to variance of YT, which is equal to sigma square E and then theta 1 square sigma square E, then theta 2 square and sigma square E, which will give you the result 1 plus theta 1 square, theta 2 square, and then sigma square. Now covariance, if I want to find the covariance one, which is equal to covariance of YT minus 1. And then if I want to write here covariance of, let me write the entire thing, ET theta ET minus 1, theta 2 ET minus 2, and then YT minus 1 equal to ET minus 1 minus theta 1 ET minus 2, theta 2 ET minus 3. Okay. So now we want to find the matching quantities here with this, matching quantity this with that. This is the matching quantity. So if I want to put them together, cov then minus theta, this is the theta 1. Yes, theta 1, ET1, and then I can write here ET minus 1 plus covariance of minus theta 2 minus 2 minus theta 1 ET minus 2. In such a case, if I want to do these computations, it will become here theta 1 minus theta 1, from here minus theta 1 sigma square 1 sigma square E, and then plus there theta 1 theta 2 sigma square E. So we have minus theta 1 theta 2 sigma square E. This is the variance covariance. So there, here I consider one leg. Okay. Now I want to consider two leg of YT and YT minus 2. And in such a case, it will be ET minus theta ET minus 1 and then theta 2 ET minus 2, and then here ET minus 2 theta 1 ET minus 3 theta 2 ET minus 3. Now if I want to multiply them, this and that is the only matching, remaining are non-matching. So it will be cov minus theta 2 E t minus 2 and then E t minus 2. And then if I want to do something in here, we have minus theta 2 sigma square E. Okay, so now for MA2 process, I have these final results. Moving average to process, I have following results. Number one, expected value of YT equal to 0. Okay, this is what I have. Now, with a variance one, the variance one, I have this 1 plus theta 1 square plus theta 2 square. So I have, this is the variance which I have 1 plus theta 1 square plus theta 2 square sigma square E. Okay. After that, then I have first order autocorrelation, first order autocovariance minus theta plus like this. And then I have second order, which I just found, minus theta 2 minus theta 2 sigma square E. Okay. And now if I want to find autocorrelation, if I want to find autocorrelation, first order autocorrelation, if I want to find, I have to put there this with that. This is the variance. Okay. So if these two things has been put, then I am getting theta 1 plus theta 1, theta 2, and denominator I am getting 1 theta 1 square, theta 2 square. Okay. And then I want to compute autocorrelations between second order and the original series. Okay. In such cases, it will be this over that, which I have minus theta 2, and then I have 1 plus theta 1 square, theta 2 square. And all other things like all other these and that, this and that will be 0, when k is greater or equal to 3. Okay, so if you put 3 in there, yt and yt minus 3, then there will not be any matching. Okay, are you understanding this thing? There will not be any matching. So after that, now if someone asks me, okay, so let me give you one example. Okay, let me give you one example because I found these things. Let me show you some example from there. I want to show you some example from there. Suppose you did some computations and get some values. Your series looks like this: yt equal to et minus e t minus 1 and then plus 0.6 and e t minus 2. Okay. So if this is your case, now if I want to compute correlation for the lag on, so are you saying there is a t minus 1, t minus 2, right? So I have a coefficient in here which is equal to -1, right? And this is another coefficient, right? This and that, this theta 1, theta 2. I want to plug it in there. In this case, if I want to plug it in there, then theta 1 is with this So my theta1 equal to -1. Okay, this theta1 is coming from there. Okay, and then plus theta1 and theta2, I am putting there 1 times 0.6. 1 times 0.6. So if you are confused why I put the negative and I put the this in this equation, because I am exactly following that one. I did it right. I did it right. I did it right. I did it right. You are 2, 1. I write him here, right? Okay. Exactly from there, I am following this theta1 and theta2 value, and then I am plug it in there, and then I am getting their value 1 plus 1 square plus negative 0.6 square. And then if you plug all of these value, finally you got 678. Okay. Similarly, these things, if this is your model, okay. So you can say that, well, when I did these things, I got the correlation coefficients in here, which I got something like 1, then this is the way you can put all of this. Okay, so and then that one equal to 0.6 over 2.36, which you are getting 0.254. Okay, general model. MAQ. After writing this, I will tell some interesting thing about my PhD thesis when I was doing. Okay, general model is like this: YT equal to ET theta1 ET minus 1 theta2 T minus 2, and it will go theta Q E T minus Q. Okay. So in this case, if I want to find, so expected value of YT equal to 0. Expected value of YT equal to 0. Series has a 0 mean, and this is what we have 1 plus theta1 square plus theta2 square plus all the way theta Q square and sigma square E. And then correlation coefficient equal to this. Here is 0 minus theta K plus theta 1, theta K plus 1, theta 2, theta K plus 2. That is by method of inductions. They have derived a series for couple of when K less equal to Q. Okay, and this is 0 when K is greater than Q. That is the formula. Okay, if we need a intercept with an intercept at MA1 model, we can write
intersect means average, right? The car company, first they said they sold 4 car, they assume that well, 4 will be our intercept, so average. So when we do not have any idea, everything is zero, what is the number of sales? First day of the opening of a car's sales center, they sold 4 cars, so that would be our intercept we can consider. So in that case, it is the first example that I give, C1 epsilon t minus 1 and then t. So this is the MA model with one intercept. Okay. So the most beautiful thing, what you have learned today, we learned time series model, but there is no calculus. Everything could be identified from mean, variance, covariance, and correlation. Understand? So take a look at that. They are modeling one with another one, but everything is determined from these 4 or 5 quantities. Okay? Everything is determined from 4 or 5. Okay? So let me tell you one interesting things. We have 20 minutes. I want to finish in few minutes. So next class, I will discuss autoregressive model and then quickly also discuss autoregressive moving average. When there is a series, some part is coming from autoregressive and some is coming from moving average. Both of them are needed. Okay, so combining these two is called the autoregressive moving average. We will try to discuss both of these. I have to be quick, and then I will discuss how your project looks like in next class. And when I was writing my PhD dissertations, started working with the professor. So they are deriving some multivariate distributions. So I was able to do it 1 and 2, 2 and 5, 6 and 7, any number. So when I and j, I equal to a specific number and j equal to a specific number, I can derive that. But I cannot generalize these things. I want to find some expression so that in that expression, I would be there, j would be there. So that anyone from anywhere, they just put the value of I and j and there. So professor was struggling with that. 2 other students already dropped out, like working with the professor previous 2-3 years, and they are not. That is very interesting, very interesting. And I was also working with them, lot of efforts. And finally, I also was not able to generalize this thing. Why I say these things? Are you seeing how beautifully generalization is done? Right? Someone put just value of the k and he will get this. Understand? So that was like deriving joint, bivariate, trivariate, and multivariate beta distribution. Okay. But I can do it for any two. Any two could be done. So after 2-3 months of lot of try, then I quit like my previous friends. So when I started working with him, the professor, so I did not know the story. Okay. So the friends who said the good luck. I did not know what does that good luck mean. Then when I started 2-3 months, then said, oh, okay, we are in the same boat. I said, why didn't you tell me before? Okay. So that was, if that development could be done, that was a very good work. Okay. But there are many things remaining in the people which is unsolved. Still people do not know how to solve it. Individually, those can be solved, but generalization is not possible. And generalization is very important. Generalization is very important. Okay. So I have 15 more minutes. So if you have a question, you can ask me. And the people who did not do well in the conceptual exam, if you can do some research with me, okay, might think about maybe research means seriousness, okay?
Serious or serious?
Serious.
Serious. I know.
Serious.
Time series.
No, you have to be serious. You have to, what works I will give, and then you have to do this.
and you have to show me the work, because I have to justify this. If I do not give you grade by the time, if I put there incomplete, so then I have to take permissions from the department, okay? So they did not do well, they are crying with me, and I cannot beat them. If they are from my country, maybe I can beat them. If they are boys, then I can slap them, punch them, but I cannot, so maybe I am giving them, okay? But keep doing well, rest of the works, okay? Rest of the works. If you see, think that if you have 2C and then you will not get the degree in from there, so you have to show some of your work. The research work, serious research work. Otherwise, I will put it incomplete there or give whatever grade you got. Okay? Understand?
What's the research about?
Research about, I know many people is in there. You can, we can have a meeting together in Zoom meeting. Okay? The research will be serious research, and you have to do the research very, like you have to give time actually. Okay, I'm going to stop in here because I'm going to stop recording this thing. So let me go and stop recording. Where should I go? Why should I go to stop recording?